Hello, we are Team 18, and today we'll be discussing our design process for our Engineering 131 design project for Tumaini Innovation Center. At Tumaini Innovation Center, students have determined that solar PV applications are what they would like to focus on.
Hi, I'm Owen.
Hi, I'm Brian.
Hi, I'm Samantha.
Hi, I'm Kate.
Our client, Tumaini Innovation Center in Kenya, has challenged us to design a tool that optimizes the school's current power, solar PV, and provide educational guidance in respect to the design. The criteria for this project are expansive. The project is twofold: design and teaching. Cost and affordability builds a need in the community, valuable, safe and reliable, maintainable, and able to be transferred between communities. It has become obvious that there are several challenges. The prototype must use a microcontroller, recycled materials, and modeling software. There is a time constraint as a result of the due date. The solution must be presented in a technical brief and a form of teaching material, video presentation, and the solution must include one input and one output. This challenge is important as the school needs a sustainable solution that results in transferable, applicable skills and knowledge to other aspects of their community. The stakeholders of this project are the students, parents, the community, the administration, and the teachers. Understanding the stakeholders in this project is pertinent to developing an appropriate prototype and teaching guide that will be useful and applicable. The stakeholders are relevant as it narrows down the scope and focus of the project as well as dictating the impact it will have. This project is globally, socially, economically, and environmentally relevant, as seen on the slide.
Our first prototype was the rotating solar panel, which was biomimicry of a sunflower. Moving parts controlled by the TI microcontroller rotate the solar panels, which would help the solar panels receive more solar exposure throughout the day. We tested this via a virtual circuit on Tinkercad with moving servo parts, as seen in Figure 3. Using time as input, servo motors moved, resulting in a 100% success rate. After creating a physical model, seen in Figure 4, we determined the design is not easily replicable and would prove difficult to teach.
Our second prototype was a voice-activated light switch that would be integrated into the power system of the Tumaini Center. We tested it using varying levels of sound inputs to see if inputs produced an output on Tinkercad. The test yielded a success rate of only 20%, which was not very effective. And after consideration of the design, it would prove to be difficult to integrate into the power system and would be difficult to teach as well. Our third prototype was a solar exposure data logging system that would be used to determine how long the sun hits the solar panels and would be attached to the side of one of the solar panels. We tested it by making a circuit on Tinkercad, as seen in Figure 1, and ensuring that it was successful with the inputs of light and the output of a time. The test yielded a 100% success rate, and upon further consideration, the idea is very simple to replicate and affordable, as well as being simple to teach.
Our final solution we chose was a solar exposure data logging system. The criteria we weighted upon is affordability, effectiveness, simplicity, replicability, ease of use, and degree of innovation. The weighted decision matrix we used to grade our prototypes can be seen in Figure 8. We weighed effectiveness and affordability of production as the most important criteria. The next most important were the ease at which the design can be taught, used, and replicated. The least important criteria was the degree of innovation of the design. We found the design that met our weighted criteria the best was a solar exposure data logging system, as it had a final score of 225, compared to the 190 of the rotating solar panel and the 125 of the voice-activated light switch. We surveyed 125 people to score how innovative each prototype was, and it can be seen in Figure 9 and 10.
Our design had to be simple, so we made the trade-off to make it not as innovative. Our limitations were that we had to use recycled materials and we had to make it affordable. Thank you for watching.